It's sometimes said that the last invention humanity will ever invent is artificial superintelligence, or ASI. The benefits of ASI are science fiction-like in their implications. In essence, an ASI would be an inexhaustible, hyper-intelligent super being with the ability to process and analyze any amounts of data in ways that we can't even comprehend yet. And if you're wondering, how do I sign up to join the waitlist for ASI access? Well, sorry to disappoint, but artificial superintelligence isn't here just yet. It's a hypothetical software-based AI system, more advanced than any human. So let's take a look at ASI and see, first of all, is it even possible? The benefits it might bring, and the potential risks, if there are any. I mean, offhand, I can't think of any obvious drawbacks of an AI more advanced than every human alive. I'm sure it'll be fine. So look, to illustrate how far off ASI is from this moment, it bears mentioning that the current level of AI is referred to as artificial narrow intelligence, or ANI. This is where we are today. Now, narrow AI excels at specific tasks like playing chess or translating languages, but it cannot learn new skills or develop a deep understanding of the world. It relies on pre-programmed algorithms and data and requires human intervention to operate. So that's where we are now. The next immediate frontier is artificial general intelligence, AGI. Now, AGI can understand the world and learn and apply problem-solving intelligence as broadly and flexibly as humans can. AGI would be capable of cross-domain learning and reasoning with the ability to make connections across different fields. Now, true AGI is yet to be developed. It's not here yet, but it is the stated goal of many leading AI organizations today. So if AGI can match the capabilities of human experts across all cognitive tasks, ASI goes the next step, exceeding those expert human capabilities. Well, is that even possible? You know what, that is a very good question. Is ASI possible? Well, let's see. Not all thinkers are aligned on the feasibility of something like an ASI. Human brains are incredibly complex and capable of remarkable creativity, problem solving, and critical thinking. So for ASI to be feasible, we're going to need a number of things. One of those is far more advanced learning algorithms. They'll need to be inspired by how the human brain learns to enable AI to improve its performance over time. This continual learning will allow AI to acquire knowledge and adapt to new situations without explicit programming. Now, today we do have a number of precursors to ASI. Generative AI, that demonstrates the increasing sophistication of AI in understanding and responding to human language. Now, it's not sentient, but this ability to understand and respond to human language in a natural way is an important building block for achieving human-level intelligence, and is a level of sophistication that seemed perhaps decades away just a few years ago before the advent of the transformer architecture. So assuming ASI might happen one day, let's talk about what some of the building blocks are to make it. So how can we build ASI? Well, this is speculation. This is not something that exists yet, but some of these building blocks are here today. So for example, we already have large language models. ASI would require access to massive data sets to learn and develop an understanding of the world, and natural language processing in large language models will help ASI understand natural language and converse with humans. Another building block is multi-sensory AI. And that will enable the ASI to process and interpret multiple types of data input, so text, images, audio, video, that sort of stuff, to perform tasks and to make decisions. And we're also seeing big advancements today in multimodal AI models. So this building block is coming along. Now, if we think about the neural network for the ASI, the neural network would need to be far more complex and powerful and advanced than the systems of today. But we'd need some other advances as well. So just as neural networks are modeled on human brain operation, there's a new type of computing we might need to use here. This is called neuromorphic computing. Now, neuromorphic computing are hardware systems inspired by the neural and syntactic structures of our human brain. And alongside of that, we also have evolutionary computing as well, which may form a part of ASI. And evolutionary computing is a form of algorithmic optimization inspired by biological evolution. So evolutionary algorithms solve problems by iteratively performing a population of candidate solutions, by mimicking effectively the process of natural selection. So all of these building blocks will prove to be important in ASI. There's probably a whole bunch of other advances that we haven't even thought about yet. All right, let's wrap this up with a good old-fashioned benefits and risk analysis for ASI. Now, in the benefits column, I think we have to add decision making. So ASI decision making will enable human agents to make the best possible decisions and solve the most complex problems facing things like healthcare, finance, scientific research, politics, and, well, really every industry. Another one would be problem solving. Now, ASI advanced thinking could be enough to solve some of the most persistent medical puzzles, to develop life-saving medicines and treatments and unlock the mysteries of physics and aid humanity's goal to exploring the stars. And then if we move a bit more down to earth, we also must consider error reduction. With its abilities to significantly reduce human errors, particularly in programming and risk management, ASI could write and debug programs and deploy robots to perform dangerous physical tasks that humans don't want to do, like bomb defusing or deep sea exploration. And then I think we should also consider creativity as well. ASI's superior creativity and its ability to analyze vast amounts of data might lead to solutions humans can't even imagine, resulting in hopefully better quality of life and perhaps even a prolonged quality of life at that. You know, this sounds awesome. I really am looking forward to signing up to this wait list, but perhaps we should take a balanced view of ASI by considering the risks. Now, one teeny tiny risk is existential. Yeah, a core worry is that ASI could surpass human control and become self-aware, potentially leading to unforeseen circumstances. Its superior cognitive abilities could allow it to manipulate systems or even gain control of automated weapons. It seems like that would be bad. Another one is automation. Now, what I mean by that is automation through ASI could lead to widespread unemployment, causing economic and social turmoil, exacerbating existing inequalities and disrupting entire industries. Yeah, on a roll here, let's go to ethics. So ethics come into play here. Simply programming ASI with human ethics and morality is complex, since there is no universally agreed upon set of moral codes. Doing so could lead to ethical dilemmas and potentially harmful consequences, especially if ASI begins to operate outside of human control. And yes, as for goals, an ASI could pursue goals that are basically detrimental to humanity, although they might seem beneficial on the surface. But without proper interventions, its advanced systems might not align with our human values. There's basically a lot that could go wrong here. So this is ASI. The potential impact is immense, with the potential to revolutionize various aspects of human life. But AI researchers, computer scientists, and world governments must carefully consider the potential benefits and risks of ASI to ensure that this transformative technology is used responsibly and ethically for the betterment of humanity, assuming, of course, that ASI ever arrives at all.
If you like this video and want to see more like it, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below.